Okay, this is the second video to Is It a Function? Alright, and what we're going to do is we're going to start to look at graphs and whether graphs represent a function or not. Okay, for each of these graphs you got to remember that the vertical line, okay, represents the output, and then the horizontal line represents the input, okay, or your x values and your y values. Alright? Alright, so what we want to do is identify whether or not each graph is a function, okay? And there's a couple ways to do it. Alright, if you remember, a function means that for every x, there's only one y, okay? For every x, it maps onto only one y. So if we had 2, well, we can't have 2 go to 7 and then 2 go to 3 or more than 1. Okay? So if I have my input, I have different values. Let's go by ones. So 0, 1, 2, 3, 4, and 5. Okay, and similar 1, 2, 3, 4, and 5 for my output. Okay? When my input's 0, my output is 2 for this point. Okay, when my input's 1, my output's 3. When my input's 2, my output's 4. When my input's 3, my output is 3. When my input's 4, my output is 3. And when my input's 5, my output is 2. Okay, so if you notice, no input has, all the inputs here have just one output. Okay, so therefore this is a function. Alright, and you can look at it that way. Alright, it's just checking to make sure that for every x there's only one y, or for every input there's only one output. Okay, the other way to do this is called the vertical line test, to see if it's a function, if a graph's a function. Okay? The vertical line test. If you want to know whether or not a graph is a function, alright, I would get a vertical line. Now, what you could do is you could use your pencil as a vertical line. Okay? I'm going to use this right here. Here's my vertical line. It goes up and down. Remember, vertical line. Okay? And what we're going to do is we're going to take that vertical line and we're going to drag it along our graph. Drag it along our graph. Okay? If that vertical line intersects 2 points or 2 parts of the graph, then it's not a function. But since it only intersects at one point it only intersects here, intersects 1 point here, intersects 1 point here, intersects 1 point here, intersects 1 point here, and here. Okay, so that's a function. Alright, now if I had put a second point at one of these, alright, and I ran the vertical line test, I would notice that my vertical line intersects at 2 points. Alright, what that means is I have an input of 3 and an output of 1, but I also have an input of 3 and an output of 3. Okay, so I have 2 answers for 3, therefore it's not a function. Okay, now you don't have to write the red part, you could erase it if you want. In fact, I'm going to. Alright, so let's check B out. B, we could use the vertical line test. It would be a good one rather than looking at each point. Okay, and you could write the points in again if you want. 0, 1, 2, 3, 4, 5. Okay, and if I run the vertical line test, I intersect at many points here. Okay, right here, my vertical line intersects these 2 points. Okay, right here, my vertical line intersects here and oops, sorry, here and here from that graph. Okay, and you know, infinite times here, 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 here. Okay, I don't have to make a point for every one. All right. So this is not a function since it intersects more than one point. All right. So we're going to write that b is not a function. Okay, because when the input is 2, we have two answers for 2. Okay, we have an output of 2 and we have an output of 4.5 or something like that. Alright, so that's not a function. You also have many spots where it's not a function, where it shows that it's not a function. We just identified one. Alright, let's move on to C. Okay, and let's try the vertical line test again. Alright, so as I'm going along with my vertical line, I notice, alright, there's no spots where it intersects this line twice. So this is a function. Alright, and here again, I'm going to label this. Okay, but if I do the vertical line test, I could tell it's not. It is a function because it doesn't intersect at 2 spots. Okay, and then the last one. The last one is what's called a parabola. Okay, and if I do the vertical line test with the parabola, I notice that it too does not intersect at any 2 points. So therefore, it is also a function. Alright, I'll keep my vertical line there and move on to the next part. Alright, for 6, they want you to find 3 ordered pairs and display them in a table. Alright, and that's why I wrote the numbers down. So when we do ordered pairs, we know what the input and output, the x and the y value is. Alright, so if I look at A, the ordered pair for 1 point, and we'll do this in red, okay, the input for this point is 1, the output is 3. Okay, the input for this point here is 3, the output is 3. And then for this point here, the input is 5, the output is 2. Okay, so what we're going to do is go back to our list. We had 1, 3, so input 1, output 3, 3, 3, input 3, output 3, and 5, 2. You can choose different ones if you'd like. Okay. For B, I'm going to choose some points for B. Alright, and I'm going to use red. So let me erase these red dots here. Okay, and I'm going to try to find exact spots. Like right here is an exact spot. I know that's 1, 1. Right here is an exact spot. That's 1, 4. Alright. What I mean by exact spot is like here, that's like a decimal. That's between 0 and 1 and between 2 and 3. I don't want to choose that. Okay. But I know here it intersects 1 and 1 at its right spot. And then we could choose this one, 2, 2. So 1, 4, 1, 1, and 2, 2. 1, 4, 1, 1, and 2, 2. Okay, what I want you to do is I want you to do C and D on your own. Come up with 3 ordered pairs for each of those graphs. Alright, number 7 is a word problem. We have to be able to fill out a table and make a graph. Okay? You are at an altitude of 250 feet in a hot air balloon. You turn the burner on high and rise at a rate of 20 feet per minute for 5 minutes. Your altitude h after you have risen is for t minutes is given by the function h equals 250 plus 20 times t. Make a table to show the altitude as a function of the number of minutes you have. Okay, and they actually do that for you. You just got to fill out the rest of it. Alright, and then graph your data points on your axes. Does it make sense to connect the points on the graph? Explain. All right, you're going to have to figure that out on your own. All right, but A, what we have to do is we have to take our minutes and plug it into the equation. So number of minutes 0, so we take the height. I'll show the work over here. H equals 250 plus 20t. Now 250 plus 20 times 0. All right, for the first one, this is where I got the 0 from. 250, 20 times 0 is 0. 250 plus 0 is 250. So the first one, the altitude is 250. Okay? Now what I'm going to do is I'm going to plot this. I'm going to do the graph at the same time. All right, so my input is 0. My output is 250. So 0, and I'm going to go to 250, and I'm going to plot my first point. Okay, input 0, output 250, and I plot that point. All right, let me do 1.5. So H equals 250 plus 20 times 1.5. All right, 250 plus 20 times 1.5 is 30. 250 plus 30 is 280. So this one right here is 280. So I'm going to go to 1.5, which is about right here for my input, and my output is 280. Now halfway would be 270, so 280 is just above that. I'm going to put that right there for my next one. Alright, one more. I'll do 3. H equals 250 plus 20 times 3 equals 250. 20 times 3 is 60, and that's 310. 310. 3 times 3 is here. 310. 300's here. 310 probably about right there. And there's my next point. Okay, what you guys have to do is fill out the rest of the table and the other points, and then I want you to do C. Okay, does it make sense to to connect the points on the graph? And you're going to explain. Okay, you have to do that on your own. Oh, okay. All right. Letter D. After 5 minutes, you turn the burner to low. This gives you enough time of heat to keep the balloon from falling, but not enough to make it rise any higher. Plot a point on the graph to show how high the balloon is after 6 minutes. Okay? I want you guys to really think about this and then plot a point, all right, for 6 minutes, where you think that point will go, whether it go, up here, and don't draw these points here. Where should it go? Where should that point go based off of your data? And then fill out, so you're responsible for DE. What's the domain of the function? Let's talk about that. The domain is what? Well, we talked about domain earlier. Okay? Alright, and if we look at our graph, the domain would be the amount of minutes, okay, you spend in the air balloon. Alright, the range would be the altitude. Alright? And then the range would be the altitude. Now there's different ways to represent it. We're going to do that later in another video. Alright, but make sure you finish what you're responsible for and turn it in when you're done.